for part B then, we're changing due to air resistance. What that means is our acceleration is going to be different because we've got different forces acting on it. On the first one, the force acting on it is just the mass pulling it downwards, so 0.2 g, gravity pulling that down there. But now we've got this 0.5 resisting it. And so the force equals mass times acceleration. The force is 0.2 g minus 0.5 equals mass times acceleration. So the new acceleration here is 7.3. And so we're going to repeat the maths we did earlier, but instead of using g as 9.8, or the acceleration is 9.8, we're now using a 7.3. So we've got u is 0, v is what I'm trying to find out, a is minus 7.3, s, the distance it dropped, was 10. So we're using a v squared equals u squared plus 2as. It drops 10, sorry. If I'm using a minus there, I had to use a minus there as well, because if the force is going downwards, or the acceleration is going downwards, I've also got to use a distance going downwards as well. So I should have just not put the minuses in at all, shouldn't I? So I've got there that v squared is equal to, that's just over 140 something, 150 something. So I've got v is 12.08. It's 146, isn't it? And the square root of 146 is 12.08. Last part, a little bit of discussion there. How will the value of x? Well, you could actually just go through the calculation, even though it says don't. But it does end up being a bit lower. It's a lower time. It turns out to be 1.48 actually. It's the height it goes up to afterwards. It's lower because of the lower rebound speed. It's lower because of the air resistance. So it doesn't bounce as high.